Welcome everybody to our next lecture regarding the feed-forward control, and in this first video regarding the feed-forward we want to have another look at the variables. So in this lecture we suppose we have a chemical process in this small box here, and now the question is, if we want to control this process, what kind of variables do we have to deal with? And so at first we start with our chemical process, which has some kind of so-called state variables. And these state variables describe the inner workings of the system. So how the system actually behaves, or what the actual state of the system is. So we can note the first type of variable. So under variable type, we can note that the state variable such state variable describes the true inner state of a system. So it captures the true inner state of the system you want to control. But of course, this is not the only variable we have to deal with. I mean, this is the one we, in the end, want to control. But we also have to say to the system what we want from the system. And therefore, we have the so-called input variables. Which also are called sometimes the manipulated variables, because we manipulate these variables in order to control the system. So we can note here that the input variables are system inputs. And these system inputs we use to change the inner state of the system. So these are system inputs we can change to manipulate the system, so that we can change the state variables of the system. So the state variables. Besides the state variables and the input variables, we also have the result of the inputs going through the chemical process or the process we want to control. And then we measure the output variables. So we can note here the output variables. And these output variables are describing what we can measure about the state variables, because the state variables are the true inner state of the system, and the output variables are just what we can measure from these state variables. So they are quite similar, but not the same, especially if we have properties we can't get a good measurement on. So then there will be a difference between the output variables and the true inner state of a system. So we can note here that the output variables are basically what we can measure, what we can see. So they capture what we can measure or see regarding the state variables. So in other words, what we can observe regarding the state variables. Or in other words, regarding the inner state of the system. So now we have the first three variable types, the input, the output, and the inner state of the system. But of course, we are not living in an ideal world. Therefore, we also have the disturbances. And these disturbances are inputs into the system, like the input variables, but we can't control them. So they are random processes, noise, and other stuff, which influences what is happening in the system, but these are variables we can't control, and therefore they are different from the input variables, which we can control. So we can note here that the disturbances are system inputs we can't control. So disturbances are system inputs we cannot control. And now we have the whole description of our variables which we need. So the input, which we can control, which are the input variables, the disturbances, and then the state variables of the process and the output of the process. Now we can further differentiate between variables which we can measure and variables which we can't measure. So we can now write down here a point regarding the variable measurement. We first have the measured variables. So the measured variables. And these we can use to control the process, because there we have some kind of value which we can compare to our target value, and then we can derive some kind of control action from these. So these we can observe. We can observe, measure, and use them for process control. In comparison to the measured variables, we also have the unmeasured variables, which are variables which we know that they are there, but we can't really measure them. For example, disturbances. If you imagine you have some kind of process which depends on a movement of a gas or something like this, you maybe know that there is some gas, but you don't know the exact movement. So therefore you know, okay, there is this kind of a disturbance, but you don't know which exact precise value this disturbance has, and therefore you can't really use it to control the process because you don't have a quantifiable value to work with. The same is true for output variables, which we can't measure in an online way, but maybe just every, for example, a few days, because we need to have a dedicated laboratory to analyze some kind of result, some kind of probe for multiple hours, and therefore we also can't use this kind of variable because it's just too slow in order to use it for process control. And therefore, when we have these kind of variables which we need a lot of time for to actually analyze and get the value of the variable, we also say that for the process control, this is also some kind of unmeasured variable because it's too slow to measure it. So we can note here that an unmeasured variable So an unmeasured variable is a disturbance or input, a disturbance or output. And this disturbance or output we cannot measure, or we are measuring it too slowly. So a disturbance or output which we can not measure frequently. And therefore we cannot use it for process control. So now you have an overview of the different types of variables which we are considering in the following parts of this lecture. We have the inputs, the outputs, the inner state of the system, and the disturbances. And we are also looking into whether or not we can measure the variable, and depending on that, whether or not we can use this kind of variable for our actually control. That covers our first lecture here, and see you in the next video.